So I'd like to express my appreciation to the organizers for giving me an opportunity to speak at this workshop. I'm a physician, and I took medical care of the survivors of the atomic bomb victims from Hiroshima and Nagasaki. I'm also an anti-nuclear activist for 35 years since I was a medical student, so you can guess my age. And I'm also involved in the activities to support the people in the Chernobyl areas for more than 20 years now. We have been working hard for many years together with you all from many people in the world to avoid repeating Hiroshima and Nagasaki, as well as Chernobyl. In spite of all of our efforts and concerns, we could not stop such a serious disaster happening in Fukushima. We are feeling deep sorrow and regrets due to this disaster. From the past 4 years, for the past 4 years, I have been working with people in Fukushima to cope with various difficulties from the radiation contamination. I started to work as a part-time physician in a clinic in Fukushima and regularly visit the affected areas. So immediately after the Fukushima accident, the Japanese government, TEPCO, and the specialists who were supporting them started to repeat, there is no clear evidence of health effects under the dose of 100 millisievert. They actually forced people in the affected areas to live under the much higher dose rate of radiation than before the accident. So you can see on this slide that such kind of TV news program was repeatedly broadcasted just after the accident. The announcer explained that even such dose of 23 microsievert per hour is safe. And he said that this number is even under the number of the one time of chest X-ray, so it's safe. So as you already know, there are many evidence that low doses of radiation have harmful effects on human population, including airborne survivors, nuclear workers, and medical exposure of fetus and so on. We also know that health risk is not limited to cancer and leukemia. Risk of non-cancer diseases such as circulatory disease is also significant even at low doses of radiation. The International Commission on Radiological Protection, ICRP, which is a kind of NGO of pro-nuclear scientists, gives an endorsement for the policies of Japanese government and the nuclear industry. The ICRP made a statement on Fukushima just 10 days after the Fukushima accident. They delivered the messages based on the ICRP 2007 recommendations. For the population of the public during emergencies, the Commission continues to recommend that national authorities set reference levels for the highest planned residual dose in the band of 20 to 100 millisievert. When the radiation source is under control, the Commission continues to recommend choosing reference levels in the band of 1 to 20 millisievert per year, with a long-term goal of reducing reference level to 1 millisievert per year. So the Japanese government is following this reference level of ICRP, they regard ICRP as an international standard. For example, now the Japanese government urged the local governments within 20 kilometers from the reactors to let evacuated people to go back to the contaminated area when the estimated exposure dose would go down under 20 millisievert per year. After all huge amount of radioactive materials were released from the reactors, beyond the 30 kilometer, the radioactive materials were spread beyond the 30 kilometer zone, which was defined as a zone for the temporary evacuation or sheltering. Now we all know that the extensive area is contaminated above the level of the control area. In the normal operation situation at the plant, only the registered radiation workers could get permission to enter the controlled area. However, because of the high population density in Japan, about 4 million people have been living in the contaminated, such a contaminated area. Even now, after 4 years, around 120,000 evacuees are still living in the temporary housing. The health condition of evacuees are getting worse in general because of the changes of living environment and stress from the hopeless situation. The severe consequences of the accident remain unsolved, and radiation risks from the reactors have been continued. The accident is actually ongoing even now. I decided to go to Fukushima for the first time after the accident at the beginning of April in 2011 because I was convinced by seeing the rough contamination map, which was drawn by the US Army, that the contamination level in Fukushima was same as Chernobyl. I thought, I have to go there and tell people the truth. So I was really shocked to see that people were living as if there was no danger from radiation in such an elevated level. So I measured 1.8 microsievert per hour in front of the Fukushima station at that time. And in many places in the city, we can measure more than now 10 microsievert per hour. So the government and pro-nuclear scientists are really guilty to force people to be exposed by telling them lies or without providing them true information. But often mothers have been suffering from such a trauma that they themselves are feeling guilty because they could not protect their children from the early exposure without any knowledge of the risk of radiation. I'm sorry, it's in already 5? I cannot speak. Already 5? Oh, what shall I do? Okay, so I cannot tell the whole things, but yeah, I can tell more in the question and answer period, but yeah, I want to just show you some pictures of Itate village, which was, from this village, 6,000 people had to evacuate it this village was situated outside of 30 kilometers. But these pictures are before the accident. And you can imagine, and this is after the accident. We measured the more than 6 microsievert per hour. So you can imagine how painful for people to leave such a beautiful villages. And I have to skip most of the things, but yeah, now they are trying to take out the contaminated soil. This was a field, but they have had to take out the rich part of the soil. The soil was, after such many years of work of the farmers, and they packed the contaminated things in such bags, and such piles of the bags are everywhere in the Fukushima prefecture right now. I have to skip all the things. And now that they studied the health research in Fukushima, but it's really, it has really problem. The research is limited in Fukushima prefecture, and they mainly focusing on thyroid cancer, and they do the health examination only the 200,000 people. But anyway, sorry, I forget to translate it in the English, but we already have the thyroid cancer, 110 thyroid cancer cases among 300,000 children. But they say it's a baseline. Even before starting this research, they named the research to find the baseline incidence rate of thyroid cancer. But they took 3 years to get this data, so we may say that some cases are developed cancer after exposure to iodine, radioactive iodine, but they never concede that they are related to the radiation exposure. So I want to say in the end, we have been negotiating with our Japanese government to give the medical support to those thyroid cancer patients. And just last month, we achieved first medical support to those children who are suffering from thyroid cancer. This is a very small step, but the first step is very important, and we are going to make more pressure to the Japanese government. And as you know, the Japanese government is still trying to restart the nuclear power plants in Japan, and we are really afraid that another Fukushima might happen if they restart any of the nuclear power plants in Japan. So we have to strengthen our movement to stop the nuclear power plants and also to support the people in Fukushima. So thank you very much for your attention.
But as a physician, how do you react? How personally do you feel when you look at Fukushima now?
Well, we never repeat such disaster in the future. So we have to start the end of the nuclear age from Fukushima. That is my message.
Thank you. Thank you very much.
Okay, before we put the official PowerPoint up, I wanted to talk about the role of luck at Fukushima. And it's something the nuclear industry really doesn't want to admit. When the was that me? When the earthquake hit, the plant shut down. But the problem with nuclear power is that only 93% of the power comes when a uranium atom splits. And this radioactive rubble that's left behind, we call it fission products, still continue to give off 7 or 8% of the heat. So stopping the nuclear reactor, the reaction, doesn't stop the heat. There's still 8% left. So when the tsunami hit about 45 minutes later, there still was an enormous amount of heat, not from the chain reaction, but from this radioactive rubble. The tsunami wiped out the cooling, well, you'll hear the tsunami wiped out the diesels, and without electricity, they couldn't cool the plant. That's really not what happened, and that is what the nuclear industry wants you to know, but it's not true. The tsunami wiped out the cooling pumps along the ocean. And just like your car has a water pump, those pumps are needed to keep your car engine cool. So even if the diesels hadn't failed, they wouldn't have been able to be cooled because the cooling pumps at the ocean were destroyed. And it didn't just happen at Fukushima Daiichi. It happened at Fukushima Daini, a little further to the south. There's 4 units there. It happened at Anagawa, which is a little further north, and it happened at Tokai, which is a little further south. In fact, 14 nuclear plants had their cooling pumps destroyed, and of the diesels that relied on those cooling pumps, there were 37. 24 of them failed. We almost were at a point where we didn't have 3 meltdowns at Fukushima, but the world could have easily faced 14 meltdowns. And it was because the earthquake occurred at 2 o'clock in the afternoon. Here's where luck comes in. 2 o'clock in the afternoon, that there was enough people on site to save the day. There was 1,000 people on Fukushima's Daiichi site, 1,000 down at Daini, hundreds at Anagawa and at Tokai. And the net effect was there were people who could bravely try to mitigate the accident. If that tsunami had hit at 2 in the morning, there would have been 100 people there. And we would have had the Daini site with 4 nuclear reactors in meltdown, and we would have had faster meltdowns at Fukushima. So role of luck is critical. The other piece of luck is that the nuclear, imagine my head is a nuclear reactor, and over here is a spent fuel pool, and over here is an equipment pool. At Fukushima Daiichi Unit 4, the fuel pool started to boil and was very rapidly getting to the point where there wasn't enough water. Well, in this pool on this side, there was water. It had been scheduled to be drained on March 10th, and Tokyo Electric was behind schedule. So this pool had water, and this pool needed water. There's a gate between them. The gate failed, and the water from the one flowed into the other side and saved the day. It's divine intervention, if you will, that saved the day on Daiichi Unit 4 because Tokyo Electric was behind schedule and hadn't drained the equipment pool. Luck, not high technology, saved the day. Okay. What's that? Oh, I click on this thing? Okay. I wanted to talk about cost, time, leaks, and exposure at Fukushima Daiichi 4 years out. The point number 1 is the cost. The costs to clean up Fukushima Daiichi are astronomical and are still being underestimated by Tokyo Electric and the Japanese government. I said when I was at the Japanese Press Club 11 months after the accident that this was a $500 billion problem. And Tokyo Electric is finally admitting that it might be 100 billion. So we now have the same number of zeros, at least in our answer. But they are not coming out and making an estimate of the total cost. And I think it's because they want to start up all the other reactors. And if people really thought that there was a $500 billion liability, that would cause the average Japanese to say, why are we trying to do this again? So costs are skyrocketing, and related to that is nobody really knows how long it's going to take to clean this up. I did decommissioning as a business when I was in the nuclear industry, and the problems at Fukushima Daiichi are not even worse, they're unimaginably worse than at 3 Mile Island. At 3 Mile Island, we had pictures of what the nuclear core looked like in less than 2 years after the accident. But at Daiichi, we can't even get near the nuclear core. And water is continuing to enter the building, and this is a problem that no one has any idea how to stop yet. So until you come up with a theory on how to stop the accident, the time is unknown. And I'll use Chernobyl as an example. Chernobyl's out there at about $500 billion, and that core never hit groundwater. That core stayed in the building, and it remained dry. So we have 3 nuclear cores in contact with groundwater. So neither the time nor the cost are known. And the Japanese and TEPCO, hand in glove, want to assure the world that the situation's under control. It is not. We have a $500 billion problem that may take 200 years to solve. And if the Japanese knew that, they would not want to start up the remaining reactors. The next point is that Fukushima continues to bleed into the Pacific. And this was known, I was saying it in April 2011. Some key Japanese were also saying it in April 2011. This should not be a surprise to anyone. Until the bleeding stops, the healing can't begin. Now, just last week, Woods Hole announced a study that showed that, about as much as 7 becquerels, and a becquerel is a disintegration in a cubic meter. So think of a cubic meter, probably about that, and there would be 7 atoms disintegrating every second. Think of 7 flashes of light every second for hundreds of years to come are in the Pacific Ocean right now. Now, this is the press release. They called it trace amounts. I don't call 7 becquerels in a cubic meter a trace amount. It could be a lot worse, but that's significant and measurable, and it's just the beginning of the onslaught. This is the most fascinating slide. This comes from Ian Goddard. There was a study in 2012 that predicted how much radiation was going to get to the west coast of British Columbia. At this point in time, the study in 2012 was 29 times lower than what they actually measured. So scientists have no clue how to measure what's transporting through the ocean. And that studies 2 years ago are already wrong by essentially a factor of 30. So if we believe the scientists in 2012, whose real goal was to downplay the significance of the damage to the Pacific Ocean, it's in fact 29 times worse than predicted. So the last piece of this is a critical study that just came out, and Dr. Kaltofen has agreed that I can be the person to announce it to the world. I believe that the exposures in Japan are grossly underestimated. You see everybody walking around with a radiation detector and measuring atmospheric gamma rays, but that's not where the problem lies. Dr. Kaltofen wrote this peer-reviewed report, and down the bottom, you can get it online. It's 170 pages long. That's on the Worcester Polytechnic website. And what Dr. Kaltofen did was he analyzed dust, common house dust, at 85 locations in Japan. And here's what he found. He found that 27% of the house dust in Japan was not contaminated. That means that 73% of the house dust that he measured in the 85 samples was contaminated. So this is becquerels per gram which is a gram is a phenomenally small piece. If you multiply that by 1,000, you'll wind up with becquerels per kilogram. So somewhere between 1,000 and 10,000 becquerels per kilogram are in the house dust in 41% of the samples Kaltofen tested. And I have no reason to believe that it's not worse than that, actually. I think we were able to get 85 samples, but in fact, if we had a larger base, I think these numbers would go up. But Kaltofen's data shows 41% of the houses have house dust in that less than 10 becquerels per gram. And it is Fukushima related because it's not just cesium-137, cesium-134. And Kaltofen got there early enough that he also captured iodine. And moving down, 25% have significant. This is in Japan. I'll show you the locations of where those samples are in the next slide. But the last number, that way down the bottom there, the 1%, is essentially nuclear fuel. Kaltofen found nuclear fuel in a dust sample 300 miles away from Fukushima at Nagoya. So this is the top 11 isotopes. This is the top 11 dust samples that Kaltofen found of the 85 that he analyzed. And look where they're from. Start at the bottom. Tokyo, 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 Tokyo. Skip one, Tokyo. Hitate. And at the top is Nagoya. So these samples are from far away from Fukushima. The only one that's reasonably close is Fukushima City, which is a taxi cab air filter. That was about 20 miles away. So what that tells me is that the Japanese are breathing in contaminated house dust in their own homes 24/7, 365. We also analyzed kids' shoes. And these are American shoes on the right, and the samples from the Fukushima prefecture on the left. What do kids do? They tie their shoelaces, they put their hands in their mouth, and one can expect incredible internal contamination from what they're breathing and what they're touching. And yet the IAEA walks around with radiation detectors and says, everything's fine, don't worry, be happy. Last slide, this is the Nagoya dust sample. There's one other piece of the Nagoya dust sample, and it's a perfect sphere. Now, what does that mean? That means it was so hot when it left the nuclear reactor that it condensed, essentially like a drop of rain. And that shows that it was essentially hot nuclear fuel that we captured in Nagoya. So my bottom line is that I have said for the last 4 years that I think somewhere between 100,000 and 1 million Japanese are eventually going to get cancer from this accident. And this data confirms that to me. Frankly, I think the IAEA and the Japanese government is in a massive cover-up so that they can start those nukes up without looking at this data. All right, thank you.
We have some limited time for questions, maybe 2 questions for either our speakers.
Okay.
First microphone.
I'd like to say our spirit greets your spirit. I'm representing some friends from the Mohawk Traditional Council in Ganawage. We've done a lot of work recently with the municipal authorities in Montreal in helping the city of Montreal pass a unanimous resolution opposing what the Canadian Nuclear Safety Agency had proposed, a study that would ultimately have led to the authorization of transporting nuclear liquid liquid waste. And I wanted to ask this question. I'd like to say, konnichiwa to Mrs. FURISTU, because I'm a Japanese Canadian from Western Canada. Namae wa Iwasa desu, okay? And I'll just say this in English and then back into French too. My grandparents were from Hiroshima. So my Japanese background is from Hiroshima. I'm a Japanese Canadian, okay? But I'm also a formal liaison with the Mohawk Traditional Council of Kahnawake near Montreal, and what I just mentioned about what we've done with the City of Montreal. Not just with the City of Montreal. I helped organize this walk on Saturday when there was 25,000 people here on the streets who were introduced to some of the native science and really some of the native thanksgiving for the air and all that we're breathing here that hopefully is healthy. My question to your two presenters is, could you actually believe that within 36 hours of the Fukushima disaster, that the traditional council in Kahnawake, through its representative, its political representative, Stuart Mayo Jr., had already written to the Japanese people, expressing not only his condolence, his concern about the disaster that had taken place, but with a CC copy to the International Atomic Energy Agency in Paris, I believe, or in Vienna, sorry. So that these two actions, what I talked about, are linked to the City of Montreal, which happened a little bit later, because of course there's local history here that we've had history dealing with toxic waste and linked to the oil industry, but toxic waste that is endangering and is worrying everybody, from city administrators to the average citizen. But could you believe that the traditional people of North America that are in a treaty relationship here in Canada, that have tools with which the City of Montreal now and any city in Canada and also in the United States can work with, for putting its governments back into place to not only listening to the people but doing what is right for our environment, that this is reality here in North America? It's a very long question, but I wanted you to get a gist of where I'm coming from, but what has been done. So we're not just talking about Canada or even Fukushima. We're talking about the International Atomic Energy Agency that's been put to the test within 24 hours. This is what traditional knowledge does. Could you actually believe that this is still happening today, and it happened here last Saturday here in Quebec City? Thank you.
I guess that comment's a very quick comment from either one of you.
I'll be really quick. People have said that, Fairewinds must have been clairvoyant because we were saying all this stuff. It was, experts around the world realized how bad Fukushima was in the first day, and most of them just didn't want that word out. So that the governments that kept their mouths shut were in fact getting the information that the native cultures knew internally, and they were getting that information from their own scientific experts, but they chose not to tell us to perpetuate the myth that nuclear is safe. But I absolutely do believe that native cultures can without the nuclear engineering degrees, can feel that danger to the world and appreciate that they detected it. Let me just do a little segue though. The Pacific is a big place. Lake Ontario and the Great Lakes are 30,000 times smaller. We're contaminating the Pacific Ocean from Fukushima. If that accident happened in Ontario, the concentration right out here in the St. Lawrence River would be 30,000 times higher than what they're measuring right now off of British Columbia. Essentially, the Great Lakes would be closed as a source of water for 40 million people, which would be god-awful.
Data, because if there's one part of the world that before March 2011 I would have thought might have been able to cope with a good record of the radioactive contamination, it would have been Japan. And I've been sorely disillusioned by the evident corruption of the information supply to Japan. And it seems to me utterly crazy and irresponsible, because even though this is an awful tragedy, there was an opportunity to get really good epidemiological data that could go for the next 50, 100 years and would really nail the problem of relating future cancer incidences to the level of contamination. So I've seen today a really good, from the new data you've supplied, a really good indication that there is a possibility that in 50 years' time we will have a good base on which to estimate the cancer incidences as a result of the Fukushima. The one thing that I would just like to add a little bit, and this doesn't undermine at all the seriousness of the situation, but people should realize that the average human being, 70-kilogram man, has about 7,000 becquerels in them already. It's not as if we are walking around becquerel-free. So it's important that people know this so that they can answer the nuclear industry when they come up with facts like this. It would appear on the surface as if 7 becquerels in a cubic meter of seawater off British Columbia pales into insignificance with the 7,000 that we've got in our bodies. That is actually obviously not true, but it's important to balance those sort of responses. And of course, the 7,000 in our bodies does not compare with the many thousands you indicated in house dust, in a cubic meter of house dust. But it's important that we are forearmed and forewarned to answer the critics who say it's tiny compared to the amount we've got in our bodies already. And of course, that 7,000 is almost certainly linked to the inevitable cancer incidence that we have in old people who after 50, 60, 70 years of this have that amount of becquerels. That comes, of course, from the internal potassium and carbon-14 that we live with every day. So it's a very different sort of radioactivity. But nevertheless, forearmed is forewarned when you get challenged with that sort of data. Thanks.
Thank you very much. One last. The lady at the front.
My name is Hyogo Collefe. I live in Ontario, but I spent about 3 months last year in Fukushima, hanging around with activists and talked to many citizens, travel all over Fukushima. My question is that now I was in the negotiation between citizens and TEPCO, and then the big problem now is the discharge of the water, contaminated water to the ocean. And they're saying that, the TEPCO is saying that 1,500 becquerel per liter as a maximum. They want to release it. And that's to the ocean. Whereas in Ontario or Canada, the tritium, then they are essentially releasing tritium, tritiated water. And here, the drinking water limitation is 7,000 per liters. And I know that I'm aware of a lot of manipulation by the Japanese government in terms of the contamination of the land. But when it comes to the drinking water or the food, it seems kind of quite strict compared to other countries. What do you think? What's your opinion on the food restriction on the contamination?
There's an international expert on tritium is here today. Is Ian Fairley here?
He's in the next room.
Oh, okay. Oh, that's right. He's giving a presentation in the next room. We're at the wrong presentation. Ian has studied, he's done a meta-study of power plant cancer statistics and pretty much nails it on the head that tritium is a lot worse than the nuclear industry would have you believe. But I'd refer you to Ian Fairley, F-A-I-R-L-I-E, from the UK. He's here today. And but the tritium, now the Canadian reactors crank out a lot more tritium than the American reactors. So what have the Canadians done? They just raised the standard. The Canadian standard for tritium is 10 times higher than what the American standard is. 300 times, oh, okay, higher than what the American standard is. So when you can't solve the problem, you just, Helen's comment is when if you can't raise the bridge, lower the water, that's kind of how you get. One of the comment there was on the types of radioactivity that are in our body. Potassium and cesium are analogs. They're above each other in the periodic chart. But the energy from a cesium particle is something on the order of 1 million times more powerful than the energy in a potassium item. So when people talk about becquerels, the becquerel is just that burst of energy, but it doesn't tell how much energy is being imparted. So when you hear about the cesium in the ocean and people say, oh, it could be radioactive bananas, it's not, because the energy of the particles that shoot out of that cesium atom or strontium atom or whatever are much more significant and not naturally occurring.
Thank you very much to all. Thanks to our speakers. And rush to your next workshop.